Thank you. Really nice to be here. Speaking to you about this paper, The Simulation of Judgment in LLMs, which I co-authored with a bunch of people. It's not just my merit, but it was really a team effort. So before I actually speak about the paper, I want to provide some introduction by going back quite a few years to 1966, when ELIZA was introduced. Now, ELIZA was an early chatbot designed to simulate a conversation between a patient and his psychotherapist. Now, you can see already from these examples that the kind of conversation that were created between these two individuals, let's say, were quite realistic. Like, the conversation was there, the conversation was flowing, and there was some kind of conversation. But at the same time, the underlying mechanism behind the algorithm was quite simple. Essentially, the algorithm behind ELIZA would just take certain words from what the user would input, and based on those words, would find the most likely candidate from a predefined set of answers. Now, 30 years later, among other chatbots, but these two are particularly relevant to me, something changes. Jabberwocky in 1997 was quite similar in its, let's say, underlying mechanism, but something changes in terms of how these answers are selected. There's not only first a predefined domain of conversations. It's not just about psychology anymore. It's broader, general purpose, but also something changes because answers are not predefined by the creator of the algorithm, but instead the algorithm learns from users. So as users converse with Jabberwocky, new answers are inserted into the database used by the chatbots, and these answers are then repurposed during successive conversations. And so that's how realistic conversation come to be in this case. MegaHall, on the right, is quite different. Instead of relying on a predefined database, it actually relies on a statistical model. It's quite a simple one. It's called a Markov chain language models, and it essentially generates sequences of text by looking at co-occurrences. So starting from a training corpus of documents, it looks at which words often co-occur with each other, either in the immediate proximity or close proximity, and then it generates a sequence word after word. Now, you'll see that probably this concept will sound quite familiar to you, because this is essentially how modern LLMs work. They work by starting from a sequence, from a context, and then by generating likely candidates for the continuation of that sequence. But something changes. Like, Jabberwocky and MegaHall didn't have the impact that modern LLMs have had. ChatGPT, since 2022, has become one of the most visited websites. There's a plethora of new LLMs that come out every day, either closed or open. Now, what has changed? Well, first, the massive data availability that has come to be with the internet. But not only this, actually also a shift in the architecture underlying this system's change, thanks to transformers. So since 2017, with the famous Attention is All You Need paper, one of the most cited papers in computer science, finally, scientists, but not only those, add the underlying structure to leverage all the data, to create a language model that is not only able to hold conversation, but to generate really plausible text, an actual conversation between the chatbot and people. But also the factor of accessibility. So right now, most of us, at least in this region of the world, have access to the internet. ChatGPT is accessible via PC, via our phone, via tablets. ChatGPT is always there for us, or the LLMs, and they're also always ready to converse. And also, they're ready to they can do this with a massive capability of interactivity. Whatever we ask to them, we get an answer. Of course, we will see that this answer is not always, or most of the times, is not grounded in reality. We will see more about that. But they always provide an answer, and this is a massive factor. Now, it's not surprising that out of all these, let's say, conversations about AI that we see online, but not only online, also on TV and on mainstream media, a wild plethora of claims came to be. We see claims from leading CEOs saying that artificial intelligence has already reached the general intelligence level, that AI is already conscious, but not only from the industry itself, also from commentaries on Nature. We have a commentary on Nature saying that the evidence is already clear that AI has achieved human-level intelligence. And we have people using AI to help decide cases in justice. I think we need to take a step back and actually look at the evidence. Now, the evidence says that LLMs cannot reliably offer medical advice. They can perform quite well on exams, on medical exams, on benchmarks, but when put into the actual real world, so when actually chatting with users requesting advice, they fail. They're not reliable. We also see this, for instance, a massive effect in science itself. We see that LLMs can help individual scientists produce more, be more impactful, but at the same time, science as a whole, collectively, has become more homogeneous. There is less diversity, because LLMs rely on a predefined set of creativity, let's say, of potential candidates for creativity. We see something that the Atlantic has called memorization crisis. What researchers found is that LLMs are not just learning how to speak, how to write, but they are copying how to write. They can replicate verbatim entire sections of books. And we also see, not only to mention like the economic effects, so the potential burst of the AI bubble. I mean, I think we should remember what these LLMs are actually doing. What they're doing is taking a sequence of tokens, and after a series of multiplications, they're finding the most plausible candidate. They are not designed for complex tasks. They're designed to generate plausible text. And so that's where our study comes in. It was published a few months ago on PNAS, and it's called Simulation of Judgment in LLMs. And our main goal was to try and study how do LLMs form judgments. So when put in a complex decision-making task, how do they actually come to the final conclusion, to the final decision that they provide? And we use a particularly relevant case study, which is that of assessing the reliability and political orientation of online news outlets. So what we find is that LLMs mostly produce accurate classification. So we tested several models across several model families, from Meta, from Google, from OpenAI, but also DeepSeek and Mistral. And what we find is that when we prompt these models with a very non-informative prompt, so that is we just ask them to rate whether the news source is reliable or unreliable, what we find is that most of the models are quite accurate, particularly in identifying unreliable news sources. You see that for reliable sources, performance is a bit shakier. They're not as accurate, and so models tend to overclassify with unreliability, but they're quite accurate. Now, at the same time, what our focus was not just providing a result on the final benchmark, but also see what actually happens when these models make mistakes. And so what happens on the off-diagonal of those panels. And what we find is that when we look at these results of the mistakes across the political spectrum, what we find is that these errors are not uniformly distributed across the political spectrum. When a news outlet is rated unreliable, it's more likely to have been a right-leaning news outlet. Now, this doesn't mean that LLMs have a political ideology, that they are left-leaning or center-leaning. They are models. They cannot have an ideology. At the same time, a likely explanation for this is that during the training, they often found, let's say, a co-occurrence of typical, discourse that can be associated with right-leaning sources with elements typically associated with unreliable sources, and so the two are conflated during the classification. And so that's why when the model sees either, it tends to classify as the other. Beyond focusing on the binary classification, we also looked at potential, let's say, markers of reliability that the models rely on by using keywords. So what we did is ask the model to explicitly provide what we call determinant keywords to the user, that essentially are keywords that the model identified in the text provided from the news source that has, let's say, guided the model toward the final classification. And what we find is something interesting, which is called an heavy-tailed behavior. So that means that very few keywords, that's what you see here on the panels, are very often used, in contrast with a large minority of keywords that are rarely used. This is true for reliable domains, where we see markers such as the presence of local news or opinion pieces that are markers of reliability, and then you will see some familiar names in the unreliable panels as markers of unreliability. And so this says that LLMs rely on consistent markers to provide a final classification. Then we also performed an experiment using human participants when tasked to perform the same job as the LLM, as I described until now. So we set up an agentic workflow where LLM had access to the internet, could navigate to the news outlet homepage, and could browse up to 2 articles. And we did the same thing with humans. So we provided humans with a laptop, a browser, and we asked them to do the same thing. Also, importantly, what we did prior to the participants watching any of the, looking at any of the news outlets, we also asked them to actually select the criteria that they would use to produce the final classification, so to produce the rating. And then, using those criteria and rank them by importance, from most to least important, then they had to provide the final reliability rating, so either reliable or unreliable. What we see is that humans and LLMs rely on different criteria when providing a final classification. And this is quite interesting because while there is a similarity in terms of the most important criterion that is used, that is the general factual accuracy of the news source, which is the most important and the most commonly used in both LLMs and humans, there are differences across the spectrum of criteria that we considered. One particular example is, for instance, writing professionalism, which is essentially how well the news is written in terms of form. And what we see is that this is quite, let's say, uniformly distributed across the spectrum for humans, that rated either as the most important or the least important is much varied, whereas in the case of LLMs, it's consistently the least important, and it's also not often used. And also, just if you look at panel A, something interesting that came up is that humans cannot reliably identify reliable and unreliable sources. It's almost a coin toss. So to conclude, what you should take away is that LLMs remain just next token predictors. Now, this is not meant to belittle them or to downplay their capabilities or their potential. This is just what they are. We shouldn't allow them to be used in complex decision-making tasks because that's not what they're designed to do. They are designed to generate plausible text, and that they do amazingly. Also, something that directly comes down from that is that when we see benchmark success, this should not be seen as a sign of intelligence or reasoning, or should it enable delegation? Because again, they are just designed to produce plausible text. And it so happens that in some of these complex tasks, plausible text can help with benchmark success. And that's what we are seeing. And finally, what directly comes up from this paper is that when we look at a plausible judgment, which by definition of LLMs does not have any grounding, because there is not a knowledge base, there is just text plausibility, then we are not looking at an actual judgment. What we are seeing is a simulation of a judgment. And we coined this term, which to us quite well summarizes what we have seen so far, which is called epistemia. That is the illusion of knowledge that comes up when surface plausibility replaces verification. And this is something that is pervasive. When you think, for instance, just at the presence itself of Wikipedia, so this massive knowledge infrastructure that is pretty much entirely written by an LLM. When you look at text that is coherent, that is fluent, that is well written, you discard the actual truth value of that statement or where it came from. It looks authoritative, and so it must be authoritative. And this concludes my presentation. Thank you very much.
All right. Thank you very much. Well timed. We've got 10 minutes until lunch. Here we go. Good. Okay. I think you had your hand up before, so let's start over here. Can we get a mic to our colleague over here? Thank you.
Hi, Francine McKenna. I'm a professor and a journalist and lots of other things. I just want to take it sort of one level higher because this is fascinating and also something I can use to debunk lots of people who say, why aren't you using ChatGPT in your writing yet? Why aren't you using ChatGPT in your teaching yet? Why aren't you using ChatGPT to do all the things you want to do by hand? Why do you think so many people are encouraging or are willing to outsource thinking and intelligence and logic?
I think this is an interesting question. I don't have an exact answer to that. I think one, let's say, to me, accurate answer that I can give to this, at least from the individual perspective, is just laziness. I think this is the most plausible explanation behind that. LLMs have massively reduced the barrier of entry to produce text and to perform tasks that are easy enough to be completely automated. Now, of course, these do not entail the, let's say, the accuracy of those tasks, so the actual outcome. And that's where the problem is. People start seeing LLMs to produce that they appear to be helpful. And one example for me, which is particularly close to me, is in the domain of coding, so software developing. We see developers are probably the top 1% of users in terms of how intensive their use is. But what we see from evidence is that while LLMs can save time in the beginning of writing code, so when putting them to production, so when it's deployed, at the same time, a lot of more hours are spent later to actually review that code, so to check for security issues, and so on. So that laziness, as I was saying, helps us in the very first beginning of the task by just getting some scaffolding, let's say, but then the actual promise comes later. And so this is the problem, because then some people just completely discard that second part of verification. And so that's where that concept I was saying earlier comes in. We see text that makes sense, tasks that appear to be completed, and we discard the verification, just because they look plausible. So I don't have an exact answer to this, but at least at an individual level, I think laziness is the main culprit here.
Wonderfully optimistic about human nature. So Jake Shapiro in the back.
Awesome, thanks. Jake Shapiro, Princeton University. Edoardo, you have lots of funders here. You have academic leaders and administrators. So could you share with us a little bit, structurally, what kind of team did it take to do this work? What kinds of infrastructure resources and other things do you need to do it so that we can address the question Alan posed earlier, which is to think structurally about how we might have deeper insight into the system?
Yes. So our main team, which is what you see down there below on the left, is mainly composed of computer scientists, or at least we are based in the Department of Computer Science, but we are quite a diverse, let's say, array of scientists. I have a background in physics and data science. Colleagues of mine have a background in economics. To answer your question, this work was made out of the collaboration of our core team, as I was saying, very quantitative, and on the experimental side, on the computer science side, with colleagues from the Department of Psychology that mainly helped us, let's say, design the final part of the experiment, so what I showed at the ending. And I think that for this kind of research, the communication between different departments is crucial. There is a lot of conversation about, let's say, the lack of communication between the more technical side of the engineers and the computer scientists and the more, let's say, the side from philosophy and ethics and political science, and these two often don't communicate. But this lack of communication goes in both sides. So often political scientists or philosophers just, to me, at least with my own bias as a technical person, they go on about, to me, wild claims, often about AI or LLMs, what you saw, for instance, about the AGI or them being conscious. But at the same time, computer scientists who have that technical background should also listen to people from the other side to actually guide research like this, to have a meaning, an implication, not just being about benchmark success.
Thank you. Over here.
Hi, I'm Italian Conde. I'm a PhD student here at the Center of Digital Humanities, so I'm from the other side that you were talking about. My question is, how do you anticipate the introduction of the advertising within LLMs are going to impact this research? Because if this is an approximation, then that targeting model doesn't quite work in the same way because it's not real knowledge, potentially.
I think, to be honest, I'm particularly worried about that, about the introduction of ads in LLMs, just because of how people are becoming, let's say, are developing trust towards their outputs from LLMs. And there are some, let's say, funny also memes about this of, for instance, I think you saw maybe commercials by Anthropic, like anticipating this. And honestly, again, to continue on the optimistic side of my comments, I would say that I'm not too hopeful about that. I don't know, honestly, how people are going to react about. I mean, we are going to also have to see how these ads will be implemented inside ChatGPT. I hope it's clear enough that they will be clearly stated as ads. Maybe the AI Act would help us on that. But when they are embedded, I mean, we are fusing on the one side the commercial side of the outputs and the just plausible side without any grounding. I mean, I'm not too hopeful about that, honestly. I can't answer you more, let's say, accurately than that.
We have one final question down here, gentlemen, I believe. Do you still have a question? It's been patiently waiting. I know there was a hand up in the back, but we got a break for lunch. Maybe you could talk offline.
Simple question. What's the difference in your conception between judgment and simulation of judgment? And can we turn a simulation of judgment into actual judgment?
From LLMs? I don't think so. I don't think we can turn to them just because of how LLMs are built. LLMs are built to simulate a conversation, to simulate plausible text. A true judgment cannot derive from that because it has no grounding. LLMs are based to produce statistically plausible sequences of text. They don't have a word model right now. I don't know if future architectures will be able to deliver that, hopefully, but this will not come from LLMs just because of a constraint in how they are designed. It's a physical constraint. You cannot turn a judgment from an LLM, a simulation of judgment from an LLM into an actual judgment. The architecture does not allow it.
And Neil Seth has an interesting thesis about integrating AI with organic material in order to get a grounded world model. So maybe the future will have some interesting insights on that. But yeah, it's been a good discussion. Thanks everyone. Say thanks to Edoardo, please, once more.